You probably are thinking, you already know a lot about rotations, so what can Mr. Nowinski teach me about rotations? Well, hopefully there'll be something in this lesson. Recall that a rotation is a transformation in which a figure is turned about a fixed point. It's called the center of rotation. Remember that whenever we talk about a rotation, we need to make reference to what the center is. There's going to be a specific angle of rotation, whether that's 40 degrees, 60 degrees, 90 degrees. In this section, in this chapter, it does say in this chapter, all rotations are counterclockwise unless otherwise specifically said. But generally speaking, when they say 40 degrees, that means 40 degrees counterclockwise. The definition of rotation, basically, if you have P, PQ, you rotate it 40 degrees, P stays fixed because it's the center of rotation, and Q is sort of swung 40 degrees. If R is out here, it's swung 40 degrees as well. Again, you have your pre-image, you have your image. Not a whole lot I can tell you. This is matching. You basically have to make some sort of estimate. 95 degrees is somewhere around 90 degrees, so I'd say this is probably going to be C right here. We have 60 degrees, which is an acute angle, so I'd say this is probably going to be 60 degrees. We already did that one, so 135 or 130 has to be this one right here. Find the value of each variable in the rotation. Basically, the idea is you have to realize that, well, let's see, x is this piece here. That means it's probably going to be 4, so x equals 4. Well, if x equals 4, that means this part equals 8, plus 6 is 14. So then we'd have 2y equal 14 because 2y is this piece here, which is the image after the 97-degree rotation. So we'd say 2y equals 14 or y equals 7. Kind of the same concept happens here. We could say 2y after it, actually 12 is going to equal 2y after it goes through this type of rotation. So 2y equals 12, y equals 6. Another way we can say this is 2x minus 4 equals x. We would subtract x from both sides, add 4 to both sides, and we basically have that x equals 4. So that's kind of how this works. Not a huge leap of faith here, but here's what it is. Rotation's about the origin. You can rotate a figure more than 180 degrees. The diagram shows rotations of the points A of 130, 220, 310 about the origin. Remember, the origin is always the point 0, 0. These words are used interchangeably. Whenever it says origin, just know they're talking about the point 0, 0 on a coordinate plane. It's very specific when things say about the origin. That is 0, 0. Do not forget that. A rotation of 360 degrees returns a figure to its original coordinates. So if we started here at A and we went all the way around 360 degrees, it would still be at A. A and A prime would be the exact same point. So here are rules. Remember, rules are not made to be broken. They're made to be memorized. This could make for a very tough quiz if you don't memorize these points here. It says when the point AB is rotated counterclockwise about the origin, again that's important, the following are true. You move from A, B, you would have the opposite of B and A, so basically you swap them and you negate the B. For 180 degree rotation, you just negate both of them. For 270 rotation, you swap them and this time negate the A. Kind of an interesting deal. Let's try this one. Let's just do the first one. It says 90 degree rotation. Let's just identify the points. So again, for a 90 degree counterclockwise rotation, if we start off with A, B, we're going to go through this and we're going to get the point negative B, or the opposite of B, A. So I'm going to list my points. Here's D, which is negative 3, positive 1. E is negative 5, 1. F here is negative 6, 4. And G is negative 2, 4. We'll go through these rotations. We'll get D prime. We'll get E prime. We'll get F prime. Oh yeah, F prime. And G prime. It's going to be awesome. Okay, check this out. There's some commas. Let's do this. So we're going to swap them. So A goes second, B goes first, and we're going to negate the B. So the opposite of B is negative 1, and this just goes over here. The opposite of 1 is negative 1, and the negative 5 just goes there. The opposite of 4 is negative 4, and the negative 6 just goes there. The opposite of 4 is negative 4, and the negative 2 goes right there. We can then plot these points if we needed to, or if we're going to do composition rotations, we could just use these points again and make D double prime or E double prime or F double prime, etc. Same things as we've done before. You can also use matrices. Check it out. 90-degree rotation, we're using this matrix. Again, we write these guys first. 180-degree rotation, we use that guy. 270 rotation, we use this guy. 360, we use this guy, which is actually the identity matrix. If you read through this thing, it says, notice that 360-degree rotation returns the figure to its original position multiplied by the matrix that represents this rotation, gives you the polygon matrix that you started with. So whatever you multiply by this is basically like multiplying by 1. You're going to get the exact same thing back, which is why it's called the identity matrix. Any matrix, any square matrix with the 1s along the diagonals and 0s everywhere else is called the identity matrix. Kind of an interesting idea. Remember, when you multiply these, you always put these rotation matrices first and the polygon matrix second. Let's try number 14 just for fun. 270-degree rotation. That means what I'll have is, I'm going to write this over here. We will use this guy 0, 1, negative 1, 0. That's the 270-degree rotation. We'll multiply this by negative 1, 2, 3, 1, negative 2, 1, negative 1, negative 3. That's our polygon matrix from up here. When we multiply this, remember we multiply across and then down. So 0 times negative 1 plus 1 times negative 2 just gives me negative 2. 0 times 2, basically I'm not going to have any x coordinates. My y coordinate will be right there. 0 times 3 plus 1 times negative 1. 0 times 1 and plus 1 times negative 3 gives me negative 3. So each of my y coordinates has become my x coordinate. Oh my. Okay, let's try this. And then we're going to negate the x coordinates and ignore the y coordinates. So negate the x coordinates. That would look like negative 1 becomes positive 1 plus 0, so we ignore that guy. Negative 1 times 2 is negative 2, and we ignore that guy. Negative 1 times 3 is negative 3 plus 0 times that guy, so we ignore him. Negative 1 times 1 is negative 1. So that's what our new points become. It says find the image matrix that represents the polygon about the origin, graph the polygon and its image. So the idea is I would plot this guy. I'd plot this guy remembering that this is A prime, B prime, C prime, and D prime. It might be kind of cool that if you drew one of them, you maybe draw like some sort of arrow that says that you went and you rotated 270 degrees, so it looks something like that. Kind of neat if you did that. You don't need to draw the arrow necessarily, but it's a good idea if you do follow the directions and graph the polygon and its image. Okay, here's the tough stuff. This is what separates the men from the boys. The composite rotations. That means you're rotating more than once. Let's check out number 17. It gives us C and D. So let's start off with these guys. We have C, which is 2, 1. We have D, which starts off at 4, 5. Okay, we are going to start off with AB, and we are going to do a 90-degree rotation. The 90-degree rotation, again, is the opposite of B, A. So that gives me C prime. That gives me D prime. Remember, I'm just switching these guys around, and then I'll negate this B. So the opposite of 1 is negative 1, and the 2 goes there. The opposite of 5 is negative 5, and the 4 goes there. Okay, that's the first part. The second part is a 270-degree rotation about the origin? No! How about the point 20? Okay, so how do you do that, guy? That's a really good question. I like this. So this is where it gets really, really, really challenging. This does not come up often. This will be basically number 38 in your homework tonight. Number 38 right there. The toughest problem in the entire assignment. Not overly challenging, but here's how this kind of works. We do know how to rotate about the origin, so all we're going to do is we're going to shift this point. Since it is 20 right here, we're going to shift this point and everything else over to the origin. So we'll shift each of these points over here. So this now becomes C prime is now sort of like -3, 2. D prime sort of acts like -7, 2. And then we're going to do, I got too excited there. Then we are going to do the 270-degree rotation like these are the actual points. And then what we're going to do is we're going to shift them back to the other way. So that's kind of confusing. So here is our first rotation. And then in order to do this, the most logical thing to me means we're going to shift everything to the left 2 units so that our center of rotation is again the origin. And then when we're done rotating however far we need to rotate our 270-degree rotation, we will shift everything back this way 2 units to kind of make up for the original 2 units. So again, here's our 270-degree rotation. If we have AB, our 270-degree rotation now is going to give us, what is that, B opposite of A. So let's see, we're going to flip them, and we're going to have the opposite of A. So this becomes, let's see, this is C prime, double prime, I guess. Let's see, so that's -3 becomes a +3, and we just shift the B over there. We have D double prime. The, let's see, the opposite of -7 is +7, and the 2 goes right there. Where'd that 2 come from? That's supposed to be a 4. Oh man. So that's supposed to be a 4. I totally wrote it down wrong. Okay, so 4, 7. Now, here's what we have to do. Over here, remember how we shifted it 2 in order to get this guy to be at the origin? We're now have to shift it back 2. So each of these points has to go back 2. So the real C double prime, we add 2 to this coordinate, so that's 4, 3. And this guy, D prime, we add 2 to this guy, so that's 6, 7. We plot these guys on here. Oh man, where am I going to plot these? Let's figure this out with some different colors. 4, 3 would be over 2, up 3 would look like that. That's C double prime. D is 2, 4, 6, 2, 4, 6, 7. This is D double prime. We'll connect these guys really fast. That's our image. The pre-image again was CD, so that's, let's see, 2, 1. That's right here. And then we have 4, 5. Let's see, over 2, 4, up 2, 4, 5. This is D. Let's see if we get the other piece in here. This is the image, I guess. So here's the pre-image. Oh boy, this is weird. We rotate 90 degrees. That's -1, up 2. That guy's right there. That's C prime. And D prime is 2, 4, 5. And then up 4 is right here. That's D prime. Okay, that's kind of weird. So we start off here. We rotate 90 degrees about the origin. That gets us there. Then we rotate 270 degrees, but not about the origin, about right here. So that's why it goes all the way around over to here. So it's kind of strange, and we're swinging around this point as opposed to this point. So that's a very complicated problem when they add in something that's not about the origin. Just wanted to show that to you and give you a little bit more detail on that, because I thought that might be the most challenging part. The rest of it I think you can figure out. Maybe check out the book a little bit if there's some crazy parts you don't understand. But the idea, our goal for today, was basically figure out how to rotate a figure about a given point. Most of the time that point's the origin. Every so often, it's not. Get out there and use some math today. Or else.